Hello, everybody. Thank you for joining us today. My name is Jodie Scholar. I'm a sales manager for Chicago White Metal. Today we're going to talk about high-pressure die casting and compare it against some alternative type processes for metals. Certainly want to thank you for your continued interest in Chicago White Metal, and for those of you who have attended previous webinars, thank you for coming back. For those who this might be the first time, welcome, and hopefully you'll get some information today about high-pressure die casting and how it might compare against some other processing options that you're looking at. Just a couple of housekeeping things. All the phones are muted for the attendees, so there is no, if you try to speak through there to ask a question or have an issue, we won't be able to hear you. So there is a way to ask questions, and I'll get to that here in a second. The reason this webinar came about, Chicago White Metal and I personally get a number of requests pretty much weekly from companies that come to me with a new part or application and say, hey, is this part suitable for die casting? And even though it might be that die casting could be used for it, perhaps there's other better options out there. So part of what I think is my job is to go through and work with the customer and say, well, maybe these other options are better suited for whatever reason, annual volume, alloy requirements, that type of thing. So it made sense to go through and do a whole webinar on some other processes that are out there to process metal and see which ones might have some advantages, disadvantages when compared against high pressure die casting. So that's what we're going to do today, and hopefully information is useful. Again, I am Jodie Scholar. Here's some info on me. I've been with Chicago White Metal going on 10 years, and I do all these webinars. So for those of you who have sat through these before, this is nothing new. On the phone also, or online, are John Miller and Mike Dimitrov, as well as I think some other experts on our end to answer your questions. So please feel free to ask the questions as you come across them. And here's how you do that. On the right-hand side, you'll see your control panel for the webinar, and there's a box in there for questions. So just type your question in, hit send, and it might take a little while for us to get back to you, depending on the flow of questions that come in, how many people, and that type of thing. But rest assured, we'll get back to you with an answer. As I mentioned, this is the most recent in a list of webinars we've done over the last couple of years. I just wanted to highlight the topics that we covered previously. So I referenced some of these as we go through the presentation today, referring back to some of the ones, the webinars we might have covered in the past. But again, we started with product solutions through die casting. We'll talk about surface finishes and a number of different other webinar topics. All of these were recorded when we did them live and are currently on our website. So we urge you to go back. If you missed one or missed all of them, go back and take a look at any ones that might have some interest for you, and hopefully that will be beneficial. So here are the different types of processes we're going to talk about today and how they relate to high pressure die casting and pluses and minuses of each. We'll look at stamping, extruding, machining. We're going to talk mostly about the automatic screw machining, and I'll tell you why when we get to that section. We look at sand casting, permanent mold casting, investment casting, which are other casting options other than high pressure die casting that might be suitable for your application, might not. But we'll cover those, what they are, when best to use them or to look that way, that type of thing. Pattern metal molding, MEM, which is metal injection molding. We'll look at thixel molding for magnesium, as well as cover plastic injection molding. So what we're going to do for each topic, or for each process we're going to look at, we have a number of factors we're going to go through and compare against. So we'll look at part design complexity, the ability, say, for stamping to make a complex part versus high pressure die casting, that type of thing. We'll look at dimensional precision, how good your tolerances can be for one process versus the other. We'll look at the processes in regards to, do they make net or near net shape components as they come out of the process, or are there secondary operations that have to take place? We'll look at the wall thicknesses. which ones need thicker walls, which ones can do thinner walls, the strength and rigidity, which also relate to the type of alloys that are available for each process. We'll look at that. What type of surface finish is created by each process. The relative tooling costs and production and material costs we'll talk about for each process compared to high pressure die casting, as well as material utilization. So if there's excess scrap that's produced, or say in a stamping, you're going to have a lot of excess scrap produced as the part gets stamped out, that type of thing. So first we'll talk about stamping. For relatively simple part designs, stamping process can be a great option for you. There are some limitations, and we'll talk about those here shortly. But the tooling cost and production costs are very, very low, especially for simple type stampings. If the part gets more complex and it requires progressive stamping dies or other assembly components to go together to make a part, then you're getting into the realm of, well, maybe it's better suited for a die casting because it can produce a part more net shape than a stamping part can. But again, for very simple part geometries and features, stampings can be a great option. So here's the table we're going to look at for each of the processes we're going through. So we'll take a little bit of time on this first one for stamping, and then for subsequent processes, we may just hit the highlights of what comparisons are better suited for that process versus high pressure die casting. So part complexity for stamping, it's relatively limited. As the part complexity goes up, it becomes more difficult to make a stamping. High pressure die casting is excellent. You can have very detailed part features in different directions, and parts can be produced that way very well. Precision for dimensions, stamping is very good. High pressure die casting is typically a little more better for dimensional ability. Net and near net shape components, again, for stamping is very, very good for simple designs that can come out of the stamping die pretty much as it's going to be used, as well as with high pressure die casting. Wall thicknesses are a big one to highlight here for stamping because you're only going to get one gauge thickness throughout the part because obviously stamping is utilizing rolls of sheet alloy that's slid through and then stamped. You can have variable wall thicknesses with die casting and can get down to very thin wall sections. Strength and rigidity is very good for stamping. You do have a limit on the amount of extra strength things you can add, such as ribs or gussets, that type of thing. That's really not going to be feasible or very, very difficult with a stamping versus what you could do with a die casting part. Surface finish is very good in both cases. Material choices are better with stampings. You can have ferrous and non-ferrous alloys than you can with high pressure die casting. We're limited to the non-ferrous alloys, so that's a biggie usually when I have a person come to me with a stamping part and for whatever reason they need it to be stainless steel or some other alloy, then that's maybe a better option than a die casting. Tooling costs are very, very low for stampings. Again, unless you have to get a very complex prog die or they have four slide dies for stampings that sometimes get a little more expensive. Production and material costs are again very low for simpler parts for stampings as they are for high pressure die casting. Material utilization is not quite as good for stampings. You're going to have a lot of excess scrap that comes off the stamping die versus what you will have for a high pressure die cast. So that is a factor to consider. So in summary, we'll look at just as a general summary. So die castings can produce more intricate parts and features on parts than stampings can as a typical statement. Stampings can do, you can do deep drawn stampings and that type of thing that help get certain features on cup shaped parts or things that have some depth to them. but again, you're still limited on the types of features you can do. Alloy choices are probably better with stampings than high pressure die casting. There are more options in the ferrous line of materials. And then the last item, scrap. You're going to have typically more scrap fallout with stampings than you will with the high pressure die casting. Okay, so second process we'll look at is extruding. Again, extruding process can be a great option if the design fits the criteria and general parameters of the extruding process. Tooling costs are very, very low, as are the part pricing, assuming you don't have to do any or many post-processing operations to the extrusion. To get the most out of an extrusion, if you could find a part with a constant cross-section that they can extrude through the die and then cut that section to length to get your actual part, and if that can be used just like that, fantastic. That is always going to be a much better option from a cost standpoint than a high pressure die casting making the same part. The problem comes in is if you have to do any kind of features that are perpendicular to the cross section, so you have holes or other features that come in that are not in that same cross section, then you're going to have to make those with a secondary option or secondary operation. So that's when you start to get into a little more costly scenario, and looking to die casting at that point might make sense because the end result from a die casting could be a less costly option. So if we look at the extrusion table here versus die casting, so some things to point out. Like I said, part complexity limited to the cross section. Again, if it's a very simple, consistent cross section and you can make a die that'll create that, the extrusion can be a fantastic option. Look down a little bit, let's see what else is on here. Again, tooling costs and production costs are very, very low. As the part comes out of the extrusion machine, anything you have to do after that starts to add into the price. So that's typically when I see something and it might have a great cross section, but then you're adding machining operations or some other operations to make the actual net shaped part, then the cost impact of extruding might get a little high. So just a quick summary on the extrusion versus high pressure die cast. Again, this is mostly alloy driven. You can do more alloy types with extrusions than you can with die casting, and it's also part design restricted. So if it's a very simple cross section and you can do an extrusion, that's great. If it becomes more complex and you need some other features, then perhaps high pressure die casting is the way to go. Okay, we'll talk about machining, and again, as I mentioned in the first screen, we're going to focus on the automatic screw machining process versus the high-speed CNC type machining. We did a webinar, I guess it was about a year ago, I believe, on converting CNC billet machining parts over to a die casting, and talked about when that makes sense and when it doesn't make sense, and the best steps to go through that. So if you have a CNC machine part and you're looking at maybe volumes going up on that and you want to look at converting over to die casting, I would suggest maybe you go back to that webinar that's recorded online and take a look at that, and where we talked about that and specifics. But today we're going to focus on the automatic screw machining, where you have a long bar stock of varying size and shape that is fed through a screw machining operation to produce very tight tolerance, typically small parts. And again, it's a great process, and for specific size and shape parts, it's fantastic. So what we're going to do is we're going to focus this the automatic screw machining against what we would think would be the competing process for die casting, which is the miniature zinc process. So that's when you see the next screen, that's what we're going to be comparing it against. And again, we did a webinar a couple years ago specifically on miniature zinc die casting. So again, there's that resource for you if you want to go back and take a look at that. So the table on the on automatic screw machining, the part complexity, you're limited in configuration for the screw machining pretty much based on the size and shape of the bar stock that you can feed into the machine. Obviously, to make some sort of boxy, square, complex-looking part is going to be very difficult through that process. Where the high-pressure die casting miniature zinc operation can make those features very, very easily and very, very fast. Dimensional precision is excellent with machining, more so than what we could do for high-pressure die casting, even though that's very good. You'll get a very tight tolerances with the screw machining. The strength and rigidity, you can get different alloy types with the screw machining than you can with high-pressure die cast. So potentially that's a restriction or a factor that's going to lead you in one direction or another, which gets down to material choices, the ferrous and non-ferrous options. With miniature zinc, we're limited to the Zamax family of zinc alloys, as well as the ZA8, which is a 8% aluminum zinc alloy. Tooling costs are very, very low with screw machining. Miniature zinc is very low as well, but not quite as low. Material utilization is often a big factor. You're going to have a good deal of scrap with screw machining than you will with high pressure die casting. So when you start figuring that in, sometimes the payback to convert over to a miniature zinc makes sense. So if you look at the main comparisons between the two, again, this is with screw machining versus the miniature zinc die casting. Alloy choices are more varied with the screw machining than you do with the miniature zinc side of things. Tolerancing are better with miniature zinc than, with screw machining than the miniature zinc side. But there's much more varied shapes and sizes of things you can do with miniature zinc than you can with the screw machining. So you can sort of see the little picture on the right here that shows some of the miniature zinc applications that we have, and you can see how that would be extremely difficult, if not impossible, to make those in a screw machine operation. So typically, if I step back and I say, okay, what do I, when I see an application come in and somebody asks me which direction to go, usually alloy type is a factor that leads somebody in one direction or another. It has to be stainless steel, or it has to be low carbon steel, or something like that a screw machine can process, and we could not. And that's usually it. That most times that's the reason when somebody would stay with a screw machine option, in addition to tighter tolerances, that type of thing. But alloy type is usually the biggie. Okay, the next few topics we're going to talk about are other type of casting processes that are out there. These are different than typically in the industry. When you hear die casting, that's referring to the high pressure die casting world. So these other casting options that we're going to look at are mostly gravity-fed options, where the alloy is poured into molds under gravity pressure, or very, very low pressure. And so that's the difference in most of these. So we'll first take a look at sand casting. And again, this is a gravity casting process where molten metal is poured into it's kind of a sand-packed molding box is what the alloy is poured into. Very, very good choice for applications and parts that require additional strength and wear resistance and operate at very high temperatures. Sand castings typically have a fairly large wall thickness to them, and can be cast out of alloys and metal types that the die casting cannot. High volumes, the sand casting starts to get a little expensive, so if there is an option to use a alloy that high pressure die casting can function with, you know, that's something you could take a look at to get a cost save. But again, we'll take a look at the table here. Dimensional precision is one that I would highlight on this page. It's below average. Again, that's because the alloy is being poured in at low pressure versus the high pressure die cast, where we can fill the mold very well and get very good dimensional tolerancing. So there's more than likely going to be some secondary operations that are going to have to be done with a sand cast part to get to the tolerances that you need. Again, that goes into the net and near net shape result. Straight out of a sand cast, that's likely you're not going to be able to use that part as is. You're going to have to do something else to the part. Wall thicknesses, generally thicker walls are required, whereas as high pressure die casting, we can do very thin wall in comparison. Because of the different alloys that are available, you can have very good strength and rigidity with sand castings. Surface finish is usually considered poor. The outside part of the sand casting is going to kind of take the shape of the sand that is being poured into. So typically has a very rough exterior to it. So possibly some additional cleanup or other secondary operations are going to be needed in order to get a final surface finish that you're looking for. Relatively low tooling costs, which is an advantage. Production costs, we say uneconomic with volume, so that it's a kind of a lengthy process to do, so it does get a little costly from a part price standpoint. So again, just as a summary, sand castings are generally used on larger parts that require very high strength, high wear resistance, that type of thing that needs an alloy type that high pressure die casting cannot. Usually used in lower volume type applications. That's not always the case, but typically, and it's going to have considerably less tolerance ability from a dimensional standpoint than a high pressure die casting. So plan on doing some secondary operations to get the tolerances that you need. Okay, the next casting operation or casting process we're going to take a look at is the permanent mold casting. It's another gravity casting process, but this uses reusable molds. So that's different than what the sand cast that we just looked at. So tooling costs are typically a little higher with permanent mold, depending on the type of material they use for the dies. But again, it's a reusable die. It can do higher volume type parts with a little easier than the sand casting. I think that's it on that page. So again, looking at the permanent mold, if you look at the dimensional precision, it's better than sand casting, but still not meeting what we could do as a high pressure die cast. So again, plan on some additional processing if you have tolerances that are relatively tight. Again, that goes along with the net and near net shape ability of permanent mold. Wall thicknesses you can do certainly thinner than sand casting, not quite as thin as what we could typically do as a high pressure die cast. So that's another issue or reason to look at one option or another. Again, good ferrous and non-ferrous alloy choices. So depending on what the application is, if there's something that needs a higher strength or a specific alloy that we can't do as a high pressure die cast, that might be a way to go as permanent mold. Again, the tooling costs are, we say, medium to high. That kind of depends on what the alloy or what the material is that you're going to be building your dies out of. It can range from the medium to pretty high, actually, tooling costs. The production or part pricing, we say medium to low. It is higher, going to be higher than the high pressure die cast, and so it's usually a lower volume, maybe 1,000, 2,000 piece quantity type project. If it's under that, maybe permanent mold is a great way to go, because when you look at the tooling expense versus the part price, it evens out a little bit at that quantity. Anything higher, typically the high pressure die cast will be a better option. So as a quick summary, again, permanent mold, you have better alloy choices than we do as high pressure die cast, or at least more varied. I won't say better, but more varied options. You can sometimes get, or typically get 100% pressure tightness with permanent mold. So that might be a big requirement for your application, where that's something as a high pressure die casting. Typically, if it's going to be a pressure tight requirement, we may go back in and say, hey, we need to add a impregnation process to help that along, where you might not need to do that as a permanent mold. So that's another factor to consider. Okay, the next process we'll look at is the investment casting, or also referred to as lost wax sometimes. Now this process results in parts that pretty closely approach the net shape and precision tolerance and other factors as we can get in high pressure die casting. Some other benefits: typically no draft is required for an investment casting. You can create undercuts directly into the mold where you can't with a high pressure die cast. That might be something that is done as a secondary operation in a machining center, for example, if you need an undercut feature somewhere. So there are some good advantages for the investment casting process. In fact, we regularly steer people in the investment casting direction, depending on the type of part and requirement. The thing here is that it's usually, again, at low quantities that where this makes sense. The process itself is rather lengthy to get to step through the process to get an investment casting made. So part pricing is considerably higher than a high pressure die cast. So it's really a volumetric thing here to see when things make sense to look at an investment casting or a high pressure die cast. So you'll see in the process table, the investment casting matches up fairly well on most of the categories, along with high pressure die cast, and in fact includes the undercuts, which we can't create in a high pressure die cast. More alloy choices than we have in high pressure die cast. So it's a fantastic process if the volume is not too high, and that's typically where we look at. So the tooling costs are going to be very, very low. So at lower volume applications, investment casting makes a lot of sense. When the volume per year of a product starts to get a little higher, then you may want to start looking toward the high pressure die cast if you can get the same level of part and requirements as you can. Then I would look at that direction. So again, just as a summary, we talked about this already, but more alloy or more variety of alloy choices that you have, you can get parts with no draft and get undercut features with an investment casting than you can with a high pressure die cast. Low tooling costs, but again, as the annual usage goes up, the part pricing starts to become the overwhelming factor of you may want to look outside an investment casting for. Okay, the next process we're going to look at is powder metal molding. This is where you have powder metal flakes that are pressed into a die at relatively high pressure and then centered to bond the metal together. This is typically done, again, this has the ability to use alloys that have a higher strength, higher wear resistance. Sometimes this is used for, when you have to have a stainless steel or a specific copper alloy that's used. So it's got some great usage for powder metal. So we'll take a look at how it compares to high pressure die cast. Some of the categories here compare very well. The part complexity, dimensional precision, net and near net shape are very, very close to high pressure die cast. Wall thicknesses you can get varied, but not too thin. Typically, the powder metal is going to be a little thicker wall section than we can in our process. But again, the very good selection and variety of alloys that are available. Tooling costs are not very high compared to us. The high pressure die cast is going to have a typical higher tooling cost. Production costs, this really looks at when the complexity of the powder metal part goes up. If there's some features in there that are difficult for them to make, it can be a less costly thing to look at a high pressure die cast. I know personally I've worked on many applications where we look to convert a powder metal part over to typically a zinc casting. The zinc alloys will have a better chance of having material properties that are more in line with what the powder metal alloys do. So we looked at converting some things over from powder metal to zinc die casting as a cost save, and it's been very successful. Again, that may or may not be the case with every application. It really depends on what type of material properties the product needs, and to see if it could be a good conversion opportunity to die cast. The next one we're going to look at is metal injection molding. That's becoming a more popular process these days with very, very small, intricate parts. This process is where a very fine metal powder is mixed with a binding agent, and then that gets heated and injects as a liquid into a machine that is very, very similar to a plastic injection molding machine. So that's how it's injected into the die. So once then the parts go through a debinding process to remove the binding agent, and then the parts get centered to remove whatever remaining binder agent is there and give it its final geometry. And that centering process alone sometimes takes between 15 and 20 hours to process. So it's a pretty detailed process and rather lengthy, but it does give the ability for very, very small parts to utilize ferrous alloys and other type of alloys that have very, very hard and good strength characteristics. So what we're going to do here, again, since these are usually limited to smaller parts, we're going to compare this to the small miniature zinc die casting process as a side-by-side comparison, because that's probably the most accurate side-by-side comparison for us to do. And again, as you look down through here, they are very comparable. All the way, the part complexity is very comparable. Dimensional precision is comparable. The big thing here is that the metal injection molding can use alloy choices that get a much higher strength and maybe more suitable for your application than the zinc or ZA8 alloys that we can utilize. Tooling costs are average, is what we're saying. It's probably a little higher than the high pressure die cast, but production costs are very high, typically compared to the miniature zinc process. So here again, it usually comes down to your application and what the material properties are needed for, and to see if there's an option to convert over to the miniature zinc process. If your product can use a zinc or ZA8 alloy, then the part pricing will be typically much better. So something to consider. Okay, the next process we're going to look at is stick-so molding. This is specific to magnesium alloys. So we'll compare this to the magnesium high-pressure die-cast process that we have. Here is magnesium alloy chips are fed through a machine, again, similar to an injection molding machine, and then heated to a semi-solid state before it gets injected into the die. Process produces parts very, very similar to mag high-pressure die casting. We have on here the process has the ability to offer improved material properties and lower porosity. I think I would agree with that, but I'd probably caution you to be careful with that claim. We've seen a number of thick molded parts come to us by customers who have not had a great experience, and when we do some sectioning and other things, they're certainly not porosity free. So just be careful with people's claims that it can be a porosity free process or even significantly lower than high pressure die cast. Other than that, the things are similar between thick molding and high pressure die cast. There are limited, very, very limited thick molding suppliers out there, and machine builders. So there's very few people who do this. If we look at the table here again, you can see these are very, very comparable, all the way down. Pretty much all of these. Now we do say not okay. So this is the thick molding is limited to magnesium alloys, where we have the ability to go from magnesium to aluminum to zinc as a high pressure die cast process. But again, we're mostly focusing here on magnesium. Tooling costs tend to be a little higher with thick molding than high pressure. But again, the processes are very similar. So again, very comparable to high pressure die casting. Again, as I mentioned earlier, we did a specific webinar a couple years ago on magnesium high pressure die casting. So if you have any specific questions about magnesium and where it's used and why it's used, that type of thing, I would suggest you go back and take a look. Okay, lastly, we're going to look at the plastic injection molding process. We see a lot of people come to us with parts that were started out as injection molded plastic, and for a variety of reasons they need to try to convert to a high pressure die cast alloy. Typically it's for mechanical properties. Somebody needs a little more strength or impact resistance or rigidity, that type of thing, then maybe plastics is not quite the right thing, and maybe one of the alloys that we have as high pressure die cast would work better. But there are certainly a number of instances where plastics will be certainly fine for your application, and we'll take a look at how things compare here. Part complexity is very, very good with both. Trying to see what some of the highlights here. Again, the strength and rigidity. Typically, we'll have to have thicker wall sections with plastic parts to achieve similar type of strength and rigidity that you will with high pressure die cast as thinner wall sections. Surface finish, you can do more things with plastics. You can have different types of textures cast in and also different colors. So that might be an advantage that process has. But again, it usually comes down to what application you have and what factors you might need for strength and that type of thing. For electronic components, a lot of times people will have to add some sort of EMI protection to their plastic part in order to get the EMI shielding that they need. Die casting, specifically magnesium die casting, will have a very similar weight to plastic, but also offer the inherent EMI protection that you'll need, so you don't have to add that as a second operation. So it could be very, if you have an application that just needs a little higher strength, or you have to add certain process steps to plastics to get it to work in your application, maybe magnesium die casting is the best way to go, because you'll be able to get the similar weight that you have with plastic and also have the added benefit of added strength and EMI protection, that type of thing. So just a few summary pages here that we'll go through and look at. Here are some examples of some of the intricate shapes and types of features that you can have with high pressure die cast parts. Some of the cost benefits that we see with high pressure die casting versus some of the other process steps we looked at. Again, can get very, very complex near net shaped designs as cast with high pressure die cast. Minimal draft angles depending on the part and the geometry of the part and what alloy you're using. Very, very good surface finishes as cast. Again, I keep harping back on previous webinars, but we did do another webinar on surface finishing for die cast. So there's a whole hour's worth of information about what you can do for surface finishing on die cast, and that is a fantastic one to go back and take a look at. Good variety of options for alloys for high pressure die cast with varying physical and mechanical properties that will hopefully work for your application. And it's a fully proven, stable process. So it's been around for a long time, and it's a proven process. Some of the product performance benefits: good strength, stiffness, and rigidity. Again, we talked about surface finishes. It provides a very nice finish for what your final finish is going to look like. Excellent RFI and EMI shielding properties, especially magnesium that we discussed. All of the alloys that we use are 100% recyclable. The aluminum, magnesium, and zinc alloys are fully recyclable, so that's a great thing to have. And it has the look and feel that only metal can provide. It's looked specifically for electrical electronic products. Again, we talked about the inherent built-in EMI RFI shielding. Very, very good thermal conductivity with the alloys that we can use for high pressure die cast. So many customers will integrate heat sink features or other thermal conductive features into a part, into a die casting. Hopefully to save money. Hopefully you can combine an existing heat sink maybe with another housing and get it all as a one-part die casting and hopefully save money that way. And the last item on here, the cast part, weighs about the same, if you look at magnesium, about the same as plastic. So it's a great option for very lightweight applications where you need a little more strength and some other mechanical properties. Some guidelines that we talk about for how to get the best results from what you're designing. Try to think about the part function first, what it's going to do, what the requirements are going to be, and then look to find the optimum process that fits. Choose a producer who offers a good variety of processes and alloy types, and I'll put in here, and who will get you going in the right direction. You know, like I said, I many times a week will get somebody come to me and say, hey, is this best fit for high pressure die cast, or maybe should I look somewhere else to for another process that will work better? And I will be straight up and tell people if it's not something that works for high pressure die cast. I'm sure there's other process steps or processes that might be better suited. Then I'll get somebody going in the right direction. We would advise to get the whoever you select for your to produce your part, get them involved early. Once again, I'm going to go back. We did the last webinar that we just finished was design for manufacturing for die casting. So it really stepped out the benefits of involving the vendor early. What's all involved with that, what benefits that has, and it was a great webinar to go back and take a look at. All post production requirements, if you could outline those as best as you can up front. This goes back to the surface finishing. Maybe in our webinar we did for surface finishing, we had the catchphrase of "start with the finish in mind," which is a little cheesy, but really is true, because if you're going to have a part that's going to have a very highly cosmetic finish with a powder coat or wet paint or something, then that will trickle back down into kind of how you design your tooling and how you do deburring and that type of thing. So it's really important for us to understand what the end result will look like or what you want it to look like, and then we can help guide you that direction. And then lastly, inform yourself on how design features impact the process success. And what this means is a lot of times very, very small changes can be done to the design or the surface finish or another feature and have a big increase or decrease on cost. So you'd be surprised at how very, very small changes could on design features could impact cost one way or another. Some of the reference materials that we use for this webinar, these are all loaded on our DC2 section of our website, as well as a tremendous amount of other resources and papers and guides, that type of thing, for a number of topics. So I urge you, if you haven't already done so, go to our website, take a look at what's there. Again, like I said, all of the past webinars are also on there that you could review, and it's actually a wealth of information on there. At the bottom, what we're going to do after the webinar here, we'll send out a link where you can download a design and specification guide for die castings. This is one of the things we have published on our DC2 Center, but we'll send you a link directly for this guide. Really is a good starting point for die casting design. Talks about all the alloys, talks about tool design, surface finishes. So it's a good overview of of how to design a die casting and a bunch of different topics on there. So we'll send a link out to that shortly after the webinar is finished. All right, again, that is going to conclude our webinar for today. Certainly want to thank you again for joining us. We should probably have another webinar, I don't know, probably early this fall on another topic. So if you, I would like to put this out. If you have any topics that you'd like for us to cover as a webinar, feel free to email me or one of our team, and we'll be happy to take a look and see if it might make sense to do it. So we're always looking for suggestions for new webinar topics. This one seemed to make sense since it was something I get a regular, like I said, weekly request from customers to take a look at a new part and see what might make sense for them to go off and look at from a metal processing standpoint. So this made some good sense to do a topic webinar specifically on the alternatives to die casting. So we'll leave this up on the screen for a bit. Continue to send in your questions. We'll stay live on the question and answer period here for a while after the webinar is over. But if you have anything specific you'd like to ask us or anything you'd like to run by us, don't hesitate to give me a call or an email, and I'll be happy to get back with you. Again, thank you very, very much for joining, and we look forward to working with you.